Good evening. Hi. Please feel free to keep eating, but I think we're going to move forward, and I'm here to introduce our speaker tonight. It's a real pleasure for me. I'm going to have a two-part introduction, so you're going to bear with me, okay? So one part is what I call the fancy part, because you're in for a treat. We have an amazing speaker here, and then there's a personal part. So I'm going to introduce Dr. Saundra McGuire. She's the Director Emerita of the Center for Academic Success, and she's a retired Assistant Vice Chancellor and Professor of Chemistry at Louisiana State University in Baton Rouge. Before she joined LSU, she spent 11 years at Cornell, where she was the director of their Center for Learning and Teaching. She was a senior lecturer in the Department of Chemistry, and she's received so many awards. I'm only going to say a few. She received there the Clark Distinguished Teaching Award. She's spoken all over the U.S. She's given talks at over 150 institutions, so I'm guessing U of R gets to be 151. In more than, almost all the states. In 2011, she was named a Fellow of the American Association for the Advancement of Science, and in 2010, she was a Fellow at the American Chemical Society, and in 2007, she received the Presidential Award for Excellence in Science, Math, and Engineering Mentoring, and she got her award in the White House at the Oval Office. Yeah, that's pretty impressive. She got her BS degree from Southern in Baton Rouge, and her master's from Cornell, and her PhD from the University of Tennessee. And she's married to Stephen McGuire. He's a professor of physics at Southern. She has 2 children, and they both have the title of doctor, which I think is awesome. And she's also a grandmother of 4 wonderful grandchildren. Now for the personal part, I want to tell you why you want to pay attention to her. So a team from my university had the wonderful fortune of hearing her speak about metacognition and how we interact with our students, how we think about them, how they learn, and how we can facilitate their learning. And we were really energized by her talk, and we went back and we pored over the materials that she allowed folks to download. We then went to LSU's website because she gave us a lot of resources there, things like the study cycle, which we use faithfully now, and we incorporated the stuff into our classes. And give another plug. So then another one of my colleagues, Ellen Goldie, I've been working with her for a while, and she does workshops on assessment. And so I wouldn't know the thing I know now about my students if I hadn't bothered to start assessing what they learn rather than about my performance. And so I just want to share, possibly for me, the best comment I got from a student evaluation this year. And so we had a question that said, what part of this course contributed most to your learning? And there was sort of like a drop down of things like activities in the class and research embedded in the labs, all these things, but we forgot to put in that drop-down list anything at all about us teaching them about their own learning. And the student didn't click anything. But in the free response part, the student wrote this. They said, well, actually, it's none of those things. 2 things contributed the most to my learning this semester. The first thing was after I failed the first exam, the instructor said to me, we believe in you, and we believe there's absolutely no reason you can't ace this course. You just need to adjust how you're studying. And then it said, and the second thing is they taught me how to study. And so pay attention to what she has to say, because she's right, and it works. And so without further ado, Dr. Saundra McGuire.
Okay, good evening, everyone. And actually, first, I want to say, wasn't that an amazing meal? Let's give those folks back there, yeah, a hand. And if you guys are going to eat like this the whole week, they're going to have to roll you out of here, I think, on Saturday morning. But I want to thank Ellen and April and the rest of the fellows for inviting me to share with you this evening something that I am now super passionate about. Oh, and I guess, do you need me to use the lavalier, Mike? We talked about that. Okay, we're good? Oh, okay. But I'll put it on anyway because I tend to roam. To share with you some information about something that I'm now passionate about, and that's metacognition, but something that I knew nothing about as recently as 15 years ago. Before I got to LSU, I did not know anything about, well, 99% of what we're going to talk about tonight I did not know. I was, as you heard, I was the, let me turn this on. Okay. Yeah, it's on. Okay, I was the director of the Learning Center at Cornell and didn't know this stuff. I taught chemistry. I had an associate director who taught what we called at the time study skills. We no longer call it study skills. We call it learning strategies. And I really didn't think that I needed to know this stuff. I was teaching chemistry. In fact, I was wondering why we even taught study skills at a place like Cornell, because my attitude was when people got to college, and certainly Cornell, they should know this stuff anyway. And then it dawned on me, oh, okay, I get it. We got to admit those kids whose parents are rich and they have money, we want them to give money to the university. And so when they get in trouble, we got to have something for them. And so that's why we have this thing. So I didn't really pay very much attention to what Helene Selko did when she was doing study skills, learning strategies. And it actually, what she was doing got my attention one time because I was teaching in a course that had 400 students there. And we would give an award to the #1 student out of all 400 every year. And I also was director of a bridge program. We had 175 students, most of whom were from inner city schools in New York City. And we were trying to help them become better prepared for Cornell. And one year, the #1 student in that 400-person course was one of our students in the summer program. And we had a course in that summer program that was, I think we called it something like critical reading and right college reading or whatever, something I thought I didn't need to know about. When he got that award, I went up and I congratulated him. And I said, you know, I know you took, and I was thinking our low study skills course, but I didn't call it that in front of him. I said, I know you took our study skills course this summer. Was that very helpful? And what I thought he was going to say is, it was all right, but I kind of knew all that stuff anyway. But that's not what he said. What he said was, I think that is the single most important course I will take my whole 4 years at Cornell. Now, that got my attention. It didn't get my attention enough to find out what she did in that course, though. So fast forward, about 4 years later, we moved back down to Louisiana. I'm from Louisiana originally. And my husband was tapped to become chair of the physics department at Southern. And at that time, the director of the Learning Center at LSU was leaving. And so I took the position thinking that I was going to do exactly the same thing I did at Cornell, which was to direct the center and teach chemistry. But no, unlike Cornell, where faculty did not send students to the Learning Center, because they probably had the same attitude I had, when I got to LSU, people were wanting me to talk to students about increasing their learning. They were wanting me to talk, to give workshops for students, to give presentations. I was clueless. Now, I had heard that there was one young lady who was, I heard she's really, really good at this. Now, I didn't know what this was, but I heard she was really, really good at it. But the problem was she was on maternity leave when I came. I started in August of '99, and she was going to take the first semester off and come back in January. And but they'd hired 2 people who were supposed to do study skills. But one day, one of them came in my office and said, Saundra, I know you're going to be talking to this student tomorrow. It was a student who was on the books to talk with her. I know you're going to be talking with him about studying chemistry. You're going to meet with him tomorrow. So can I sit in on that session so I can find out what to tell students about how to study? It's like, this is not good. And then the next day, the other one came in and said, Saundra, this boy is supposed to come talk to me about test anxiety next week, and I don't know what to tell that boy. This is exactly what she said. I don't know what to tell that boy. And so I knew we were in trouble. So I called up Sarah, because her baby was a month old by then. So I figured she was ready for some adult conversation. And so I said, Sarah, I know you were planning to come back in January, but would you consider coming back just 10% time? Just give me 4 hours a week, because we don't have a clue. And we know that you're very, very good at this, but we don't know what this is. And so she said, sure, I can do that. And so the first thing I had her do was a mock individual consultation with one of the students that she'd worked with. And I had him sit at a table, and we watched what she did. And when I saw that interaction, that's when the flash bulbs went off for me. I knew that there was this whole body of information that if I knew it, I could be much more effective with students, but I didn't know it. And so I started reading everything I could get my hands on and came across the construct of metacognition as a way to have the conversation with students about their role in the learning process. Because I had been to many, many, many workshops as a faculty member on improving our teaching strategies, and they were great workshops. We learned a lot of strategies, but they always seemed to me to be leaving out 50% of the equation, because we could be the best faculty on the planet. But if students come to the table not knowing what their role in the process is, we're not going to see the kind of learning gains that we could if they were partnering with us. And so I love what Pulse is doing and SERP partnering to really change undergraduate biology. And so the Pulse charge is you're trying to inspire whole departments to undertake the reforms called for in this vision and change in undergraduate biology education. And the ultimate goal, and I guess I can use the pointer here, the ultimate goal is to develop and grow communities of scholars at all levels of the educational process, from undergraduates, so we're talking about communities of undergraduates, faculty, and administrators, all committed to creating, using, and assessing, and disseminating effective practices in teaching and learning. And so what we're going to be talking about is using metacognition as an effective practice in learning. And I can tell you, nobody was more surprised than I was at how effective these strategies were. And April, thank you so much for sharing that strategy, sharing your experience with them. Because when I first heard about the strategies, I really didn't think they would work that well. I thought that they were too straightforward. I didn't think students would use them. So I didn't think they would make that much difference. But I would find myself, I was walking across campus, and somebody, maybe 50 yards away, Dr. McGuire, that stuff was so helpful. I'm making an A in that course now, and I was flunking it. And I'd go, really? That is fantastic. Now tell me exactly what was it I told you that you're doing? And so over the years, I am confident, I've heard it so many times that I know what works, but I still ask students, and I encourage you also, because I know everybody in this room, you've seen those kinds of things where students have turned things around. But what I do now is I ask students exactly what strategies they use, and then I have them send me before and after scores, and I use that with other students to motivate other students. And so what I want to do is before we talk about the definition for metacognition, I'm going to tell you about a student whom I met September 13th of 2013. I'm sorry, September 23rd of 2013. This student was in an honors chemistry class. And so now what we do is we will go in and do just one 50-minute presentation to classes when faculty invite us in. And so I was there to do a presentation to this honors chemistry class after the first exam. We don't try to do this before the first exam, because if we try to do this before the first exam, what happens? Exactly, nobody's listening. They kind of, it's like almost like, well, if you think I need this stuff, they kind of go into Beyonce mode. You must not know about me. You must not know about me. I don't need this stuff. And so we don't do it until after the first exam, so they see that maybe they do need this stuff. And we don't tell them that somebody's coming to talk about learning strategies, because if we tell them that, what's going to happen? They're not going to show up, exactly, even after the first exam. And so I went to the class, and I always get there very early. And so there was this one young lady already in the class. It was about 7:30. The class started at 8:30. And so she was the only one in the class, and she said, oh, you're going to teach us today? And so I said, yeah. She said, what are you going to talk about? And I said, I'm going to talk about learning strategies. How are you doing in this class? And she said, oh, I'm doing great. She said, I did great on the first exam. I didn't think I did so well, but I did great. I made 97.5. And so I said, oh. Now, what I knew was that the total number of points on the exam was 150. But, but what I didn't know is I didn't know if she had already done the translation, and so she made 97.5%, or if it was 97.5 out of 150. So I said, oh. I said, well, you know, the total points on the test is 150. So was that 97.5% or 97.5 out of 150? And she got this deer in the headlights look on her face. Yeah. And she said, I don't know, let me check. And so she went to her laptop, she went to the Moodle site, the course management site, and I was watching her, she was looking at her screen, and I saw these crocodile tears start to, yeah. And so she discovered it was 97.5. I said, oh, but don't get discouraged yet, because we're gonna talk about some stuff that'll turn all that around. And she said, no, you don't understand. I just got my calculus test back last week, and I got a D in that also. Now, here's this kid, you know, straight A student in high school, honors chemistry. She wanted to be pre-med, so now she's got 2 Ds. And so I said, well, still, don't be discouraged yet, because we're really going to learn something, and it'll turn everything around. And I asked her if she had a class right after the presentation, because as devastated as she was, I knew that I probably needed to talk with her and give her, you know, a little bit more of a confidence boost. And she didn't have a class after that, so I took her to the office, and we talked for another maybe 20 minutes or so. But basically, it was a, you can do this, the kind of thing that April said. You can do this, I know you can do this. And so on October 14th, she sent me an email. This is Sydney Landry, the student you talked with after giving the CS presentation to Dr. Cook's Honors Chem 1421 class. I just wanted to thank you for giving me the tools I needed to succeed in my classes. I also wanted to update you on how I'm doing in my classes. I recently took my second math 1550 exam, calculus exam, and earned a 100% A. Getting the most out of my homework definitely helped me to achieve that score. I'm scheduled to take my second Chem 1421 exam this Wednesday, October 16th. I've been preparing for this exam since the day I talked with you. I definitely feel more confident going into the exam. Okay, and so I got an email, a copy of an email that the professor wrote to her. She made an A on the chemistry test. And then I didn't hear from her at all. And I was speaking at Indiana, University of Indiana in January, on January 9th, and I thought about Sydney, and I said, let me see how the semester turned out. So I sent her a quick email. And so she wrote me back. She said, hi, Dr. McGuire. I'm so happy you emailed me. I'm also happy to let you know that I finished the semester with a 4.0 GPA, smiley face. I finished both Calc and Chem with an A. I earned a 96 A on my Chem final after some hard studying, and an A on my Calc final as well. Your tips and encouragement were definitely a factor in my success. Thank you so much, with about 8 O's after the S, so much. I'm also enrolled in Honors Chemistry 1422 course for the upcoming spring semester, so I'm excited to utilize your tips for Dr. Cook's class and for the rest of my college career. And so the stuff that we're talking about has this kind of impact on students. And so basically, we're talking about metacognition. And so metacognition is just a term that was coined by a cognitive psychologist, John Flavel, and it's your ability to think about your own thinking. And the way I explain it to students is I say, it's kind of like as if you had a big brain outside your brain looking at what your brain is doing. And that big brain is saying, is she just memorizing this stuff for the exam, or does she really understand it? It's saying, is she, if she's got a paper that's due 2 weeks from now, does she know that she needs to get started on it now, thinking about it, maybe use the writing center, or does she think she's just going to whip it out the night before? And so it's your ability to be consciously aware that you are a problem solver. Have you noticed that currently many students, I find so many students are in what I call victim mentality. Have you noticed that? Yeah, everything's, well, I didn't know there was going to be a test today. Well, I didn't know we had to type the paper. I mean, it's like, it's not my fault. You know, I didn't know. How was I supposed to know? But if you're using your metacognitive brain, you recognize that everything is a problem that you can generate strategies to solve. So it puts people more in proactive mode as opposed to reactive mode. And so when I talk to students, I say, so, you know, your number one problem here at this institution is how can I maximize my learning? And so then that metacognitive brain starts working. And it says, well, you got to go to every class. You got to read the syllabus. You have to interact with the professor. You have to talk with students. And so you're consciously aware of what you're doing. And I tell them, I'm not saying that you can solve problems without using resources. I'm not saying that, but the metacognitive brain is going to help you identify what resources you need to use, but you know that your learning is within your control. It's not somebody else's fault. And it's your ability not just to monitor your mental processing, but to plan and control it. If you have a problem, for example, if you are a procrastinator, then you might say, oh, I procrastinate. I always get started late. And I know it's a problem, but I'm just a procrastinator. But if you're using your metacognitive brain, then the metacognitive brain says, this is the problem. We have to solve this problem. And so then I ask students, if you want to know something about a subject and you don't know anything about it, what do you do now to find out information about it? Google it, exactly. And that's what the students tell me, Google it. And so the metacognitive brain says, well, we need to Google how to avoid procrastination. And if you Google how to avoid procrastination, you will see all kinds of strategies for how to avoid that. So it gives students a different way of approaching their activities in their education. And it's your ability to accurately judge your level of learning. And that's where Bloom's taxonomy comes in, and we're going to talk about that in a little bit. But I know we, and somebody earlier called them HOCs, higher order critical cognitive skills, yeah, higher order cognitive skills. And we call them HOTS, higher order thinking skills, And so we're always saying we want students to think at higher levels, right? Okay, and so when I talk to students, and I talk to students in many places around the country when I talk to faculty, and I'll ask students, how many of you have ever heard your professor say, we're going to work at higher levels, we're going to think at higher levels in this course? Almost all the hands go up. And I say, who can tell me what they mean by those higher levels? Can anybody tell me? Nobody can tell me. And so if students don't know what those levels are that we're talking about, then there's no way that they're going to reach them because they don't even know what we're talking about. And so if you're using your metacognitive brain, then you know what the levels are, and you know that you've got to be at higher levels, and we're going to talk about how we teach students to do that. And so the fact of the matter is most students have not developed these metacognitive skills because it just wasn't necessary before they come to us. And we see a lot now about, students are just not prepared for college. Well, of course they're not. But that doesn't mean that they shouldn't be there. It just means that we can do what we need to do to make up that gap. But we can't do it if we don't know the language to use to help students understand what we're talking about. Because before, if a student came to me and said, I am having so much trouble with chemistry, but I study all day long and I'm still making C's, what should I do? The language that I had was I'd say, well, you need to work more problems. Or I might say, you need to focus on the concepts. You can't just memorize information. I might say, you need to spend more time on chemistry, not realizing that that does not translate into any actionable items on the part of students. But now I do know what to say, and this is what we're going to share tonight. These are data from the UCLA Higher Education Research Institute study, and they do this survey of first-year students every year, and these are 2010 through 2013. The percent of students who spent less than 6 hours a week doing any homework in 12th grade, almost two-thirds%, I'm sorry, not two-thirds%, almost two-thirds are approaching 66% in 2010. Now, the good news is it went down in 2013 to 58.6, so more of them were spending more than 6 hours a week. But the percent who graduated from high school with an A average for the first time in 2013 was over 50%. And so these kids are not spending a lot of time, but they're graduating from high school with an A average. And so there's no surprise that when they get to us, they think that they're going to be able to do what they did in high school. And the 2013 SAT report said that fewer than half of the SAT takers in the class of 2013 graduated from high school academically prepared for the rigors of college-level work. And that's not a surprise. I don't think that's going to change anytime soon. And so what we can do is make up for that gap in their preparation. And so I think that we as faculty, we can help them identify that gap and close the gap between their current behavior and the grades that they're getting, the learning that they're getting now, and productive behavior that's going to get them the desired learning and the desired grades. And so what we've got to do is turn our students into expert learners, teach them how to learn, and this involves teaching them metacognitive learning strategies. And so what I'm going to do during this talk is I'm actually going to take you through the process that we take students through to get them to understand exactly what the difference is between what they were doing and what they need to do. And it starts with a couple of reflection questions. And so I'm going to ask you these questions. I'm going to give you about a minute to get your own answer, and then a minute or so to share with your next door neighbor or in groups of 2 or 3. And then we'll come back in a couple of minutes and see what we think about these 2 questions. The first question is, what's the difference, if you think there's any at all, between studying and learning? And then the second question, and we're going to answer the second question with clickers. And so let me just say that I put 4 clickers at most of the tables. And so we're going to have to, you can think of this as kind of a think, pair, share with the clicker questions. And so get an answer between the 2 of you, and then just weigh in with what you think. And if anybody's at a table that doesn't have a clicker, then just get to a table that does. And if anybody has an extra clicker at their table, because we are wanting you to work in groups of 2 or 3 with the clickers, then just let us know. So we want everybody to have access to a clicker. So the second question is, I give them 2 scenarios. And I want to know, would you work harder for one of these than the other? And I want to know what your answer is, not how you think your students would answer. And so the first scenario, as I said, suppose I said, 2 weeks from now, we will have finished the first 4 chapters, and I'm going to give a test on that material, and you have to make an A on that test. That's scenario A. Scenario B, I say, 2 weeks from now, we will have finished the first 4 chapters, and I've decided that I'm going to give a test, but the day before the test, we're going to have a review session. I'm going to offer a review session, and you're going to teach that review session. So I'm going to have you come up to the front of the class. You're going to explain all of the concepts, paying particular attention to the concepts that were more challenging to make sure that everybody is prepared for the test the next day. Would you work harder for one of those tasks than the other? And so, again, take about a minute to get your answers to those questions, then a minute to share with people at your table, and then I'm going to put the next slide up where you'll be able to vote in with the clicker. Okay, now on the first question, I can tell you I've asked that question to now, I'm sure, over 10,000 people all over this country, some other countries. And there are no right or wrong answers to any of the questions I ask. And this is what I tell students. I just want to know what you think. And so for the first question, I always ask, does anybody think that they're exactly the same thing? And in a couple of settings, there have been a person or 2 who said they're exactly the same thing. So I'm going to ask here, is there anybody who would say they're exactly the same thing? Okay, so would somebody share with the group how you characterize the difference between the 2? We're so much like our students, aren't we? Okay, so we got 1, 2, 3. Okay, yes.
So we talked about levels of expertise.
Okay.
Thinking about when we were undergraduates, what studying meant, and how we probably as a population were kind of exceptional as undergraduates because we managed to make it through the gauntlet and become professors at the end of it all.
Okay.
And that now when we think about teaching out material and what we have to do to learn it, to teach it, it's kind of a whole different ballgame than what we might expect from undergraduates.
Okay, so what did you say is exactly the difference between studying and learning? Okay. They didn't exactly get to that part. They were moving in the right direction, though. Okay, thank you. Who was number 2? Yeah, back here? Yes.
We were actually talking about is a lot of times, depending on the kind of test you're administering, it's a lot of times memorization or regurgitation for the test is short term.
Okay.
Teaching material, especially if you want to really teach it in depth, you spend years preparing for it.
Okay, got you. Okay, and so, yeah. And so both of you are certainly on, and what you're saying is that the kind of studying you did in college and versus later, or even high school and later, was very different. And you're saying that you focused on maybe memorization and regurgitation, whereas if you've got to teach something, then it may take a lot longer to actually master the information. Okay, great, thank you. And then 3, yes.
We were talking about it, so we thought of studying as strategy and learning as an outcome, and they weren't always
Got you. Studying is a strategy, learning is the outcome. Now, I very often get that answer from faculty groups. They say studying is the process, learning is the product. I've never gotten that from students. But you're right, that's the way it should be. But when you ask students that, the most common answer I get is, and nobody's asked them this before, so they haven't really thought about it, but they will say, like the answer back there, studying is just memorizing information for a test or a quiz, but learning is if I understand that information. Sometimes they'll say studying is short term, learning is long term. Sometimes they'll say studying is tedious and boring, learning is fun, but they get the difference. And then when I ask them, okay, up to this point in time, have you spent more time in study mode or in learn mode? What do you think they tell me? Absolutely study mode. And I tell them yes. And so that is part of why they're not acing all these courses. Because, and I try to really reinforce with students is that it's not that you're not doing well because you're not smart enough. Because have you noticed that a lot of students will fall back on that, oh, I must not be as smart as I was before, and they tend to want to give up. No, that has nothing to do with it. How you're doing has nothing to do with how smart you are. It has everything to do with your behaviors. They think that you can't change how smart you are, although we know that's not true either, but they know they can change their behaviors, and so that's motivating to students. Okay, and so the first part then is you've been in study mode, you need to be in learn mode, and I can show you what that is. Yes? Mm-hmm.
I work with a lot of honor students.
Right.
When they're put in this situation,
Mm-hmm.
they feel that they own the material that they're trying to teach.
Right, exactly. Okay,
That concept of ownership.
exactly. Once you know it well enough to teach it, it's like you own that information. And you will know that long term, you can apply it absolutely. Okay, now, and so for the second one, we're going to do this as a clicker question. And so I want to know, you personally, for which of those two tasks would you have worked harder? To make an A on the material, to make an A on the test, or teach the material? And so if you want to just confer, with your partners and come up with an answer. And you can see the responses are up here. And there are about 45 clickers out there. And I borrowed these from LSU, and I promised my firstborn grandson if I don't if I don't take all of them back. So please make sure I get them all back. Okay, and so when we get to about 40, I will, for each of these, okay, we're at 40. Okay, and so I'll give you the 5-second warning. Okay, yeah. And this is exactly the same thing with students. Most of them say, well, I'd study more if I had to teach the material. And I said, well, why would you work harder if you had to teach the material? Well, I got to really know it if I have to teach it. Yeah. And so it's like, guess what? You kind of have to know it to make an A. But there's no reason that they would ever know that, because they didn't have to know the material in high school to make an A. And you only have your experience. And so if you've never been in a situation where you had to really know the stuff to make an A, it's not just going to drop out the sky that's what you have to do. So they don't really know that. Now, a few people do say make an A, and I'm just going to ask one person who said make an A, tell us why you said that. Who said that? Okay, yes, and why did you say that? I mean, why would you work harder to make an A?
Well, I'm a student.
Okay. Okay. All right, got you. Okay.
So personally, I would be that student that's just like, oh, I hope the professor doesn't pick on me to teach the material.
Ah,
So that would be my life.
interesting. But if you knew that you had to teach the material, would you work harder?
Yeah, I would definitely work harder because
Okay.
I know that I'm going to have to teach it, which is going to in turn help me.
Got you. Yeah. And typically students who say that are kind of like you. They said, I am a student. And many times they'll say, well, if I prepare to make an A, I know I'll be able to teach it. That's not very often. Yes. Oh, yeah, exactly, yeah. In fact, I hear what you're saying, and that is the number 2 reason that people give me. When I say, why would you work harder for A? In fact, it's kind of tied with, well, I got to know it to make an A. Many students say, well, I don't want to look stupid in front of the class. And so and sometimes they say, well, I'm anticipating questions that are going to be asked, and I want to be able to answer those questions, and so they work harder. And so then I say, okay, well, the good news is that you don't have to have your own class to be in scenario B mode. If you have, and I kind of make a little joke out of it, if you have empty chairs in your room, if you have stuffed animals, if you have imaginary friends, if you have any audience that you could pretend that you're teaching the material to, it makes a difference. And the reason is this, and I will ask the group here, how many of you have ever been in a situation where you thought you understood something totally, and then you started to explain it to someone and you got stuck? I asked this to students, and yep, it happens to everybody. And then I said, okay, and if you get stuck, but you really want to know this, what do? And they say they go and look it up. And I said, absolutely. And so the benefit of this is, if you had not been in the process of pretending that you were teaching this, when would you have found out that you didn't really totally understand this? And when would they have? On the test, exactly. And they get it on the test. And so then I ask them, up to this point, have you been more in scenario A mode or scenario B mode? And what do you think they tell me? A, exactly. And so a lot of my graduate students, they'll say they went out and bought a whiteboard, put a whiteboard on their wall. Some of the undergraduate students said that they would just routinely go to an empty classroom and practice. Sometimes they say they'll try to explain it to their roommates or their friends. We had one vet school student who was flunking animal physiology, and she came to get some strategies, and so I talked with her, and she came back. She made an A in the course, and again, I always ask students, what did you do? And so I said, well, what exactly did you change? And she said, Dr. McGuire, I have the smartest dog in animal physiology on the planet. She said, every day after the class, after animal physiology, I would go home and I would teach him what we had learned that day. And so it's these kinds of experiences that will help students really understand what's going on. And so I said, okay, now we have two pieces of the puzzle. You weren't doing well, not because you're not as smart as you were in high school, because you are, not because you're not capable of making straight A's here as you were there, but you were in study mode, not learn mode. You were in make an A on the test mode, not teach the material mode. And then there's one other piece of the puzzle that we'll see in just a little bit. And so now I want to tell you about 2 students and the scores that they made before they learned effective strategies and the scores that they made after strategies. And I'm going to tell you exactly what the strategies were, because you can start using this stuff, next time you have students. Okay, so Travis was a junior in psychology. He made a 47 on the first test, 52 on the next test. And I actually talked with him by phone about 30 minutes the night before the 3rd test. Because have you noticed our students are so busy these days? You notice that? Yeah, and so the instructor was trying to get him to come in, but he was just too busy. So finally, I talked with him 30 minutes the night before the test. I thought he was going to make in the low to mid 70s on the test. 20-point bump, I figured, 30 minutes the night before. So he calls back, though, and he made an 82. And he was so excited. He said, Dr. McGuire made 82 on that test. I said, wow, Travis, that's fantastic. If you make higher than N, and I was trying to think of a stretch score that he would never make higher than, I said, if you make higher than an 86 on your next test, I will take you to lunch. Now, I thought that the 82 was a fluke. And I thought at least statistical regression would kick in. But he called back and he made an 86. And so I said, wow, Travis, that is fantastic. Let me get back to you and we'll set a lunch date. So in the meantime, I contacted the professor to verify that this self-reported 86 was actually an 86, because I was not going to take this boy out to lunch on a humbug. But the professor said, yeah, he made an 86, and so I took him out to lunch, and I said, Travis, what are you doing? And he said, well, I'm just doing that stuff you told me to do. And what I told Travis to do was a reading strategy. And when I talk with students, I ask them, how many of you are in classes where you have to do a lot of reading? All the hands go up. And I'll ask you out there, how many of you have had the experience where, you start to read and you're going right along, and then all of a sudden you realize that you're not paying attention to what you're reading anymore, okay? And that happens to all the students. And then I ask, at that point that you discover that you're not paying attention, what do you do at that point? Okay, now somebody said put up the book, And occasionally students say that, but that's very rare. What do you think most of them say? They reread, exactly. Most of them say they reread. They go back and reread. And so I tell them that the problem is, you might get a little bit further the next time, but because you don't have any different strategies, you're not going to get much further. And so the strategy that I learned, I actually went to a 4-week workshop. There's an international, it's IRD are the initials. They do these summer workshops all around the country. International Reading Development or something like that. And there were so many students at LSU coming to me saying that they were having difficulty with reading. Could I teach them reading strategies? And I didn't know how to teach them any reading strategies. So I went to this workshop thinking that I might pick up some strategies that would be useful. The workshop was invaluable. What I learned in that workshop is, first of all, why it is that most of us, when we start to read, our mind starts to wander, why we don't remember, why we don't retain a lot of what we read, is because we start to read and then our mind starts to wander. And I learned the way to prevent that. And the way to prevent that is, before you start to read, you've got to get an overview. You've got to give your brain the big picture of what you're about to read. We know from cognitive science, the way the brain is more efficient, that if it starts with a big picture, with an overview, and gets individual details to fill in that big picture, it's much more efficient than if it just starts out reading, getting individual details and trying to create its own big picture. So you gotta get the overview, and you can do this by looking at the boldface print, the italicized words, any charts or graphs. And if it's a book, let's say a novel or something that doesn't have those kinds of markers, you could just read the first and last sentence of every paragraph, break it up into small sections, and do this. So you've got the big picture. And then the second thing to do is come up with questions that you want the reading to answer for you. So let's say if you were reading a chapter that involves cells and you saw eukaryotic cells and prokaryotic cells in italics, you might say, well, I wonder what this thing is going to say the difference is between prokaryotic cells and eukaryotic cells. So now you've given yourself a purpose for doing the reading. And then the next thing is, when you start to read, you want to just read one paragraph, just the first paragraph. You stop, put that information in your own words, and then read the second paragraph. Stop, put that information in your own words, and try to fold in what was in the first paragraph, and then read the third paragraph the same way. Now, when I talk with students about this, I always ask, does that sound like, if you do that, that it's going to take you a long time to get through the reading? And what do you think they tell me? Absolutely. But I tell them, this is true, every student, and I ask students, did you try? Because they'll tell me, oh, it works. And I said, did it take you longer to do the reading that way? And they say, no, actually, I finished the reading sooner doing it this way than the way before. And then I'll ask them, why did you get through it sooner? And then I ask the students, and I'll ask you, why do you think it would take less time to do it this way than the way they were doing it before? Exactly, that's what students say. They said, you're not going back and rereading. And then they say, you're more focused. And absolutely, because the old way, what was happening is you'd read a little bit, go back, read, go back, read, go back, read, go back. And so with the new way, you're moving more slowly through the material, but you get to the end point sooner because you're not going back and forth. And the other thing that happens is, after about the second or third paragraph, your brain gets the idea. It's like, okay, she's going to stop, make me put this stuff in my own words. And so it focuses in on the reading with the idea that it's got to paraphrase the information. And so it's really focused a lot more. And then the third thing is, and I ask students, can you imagine that when you get to paragraph 6, if you've understood everything in paragraphs 1 through 5, are you going to be able to read paragraph 6 quicker than before? And they agree with that. And I've had law school students, I've had grad students tell me that once they start using that reading strategy, it really made a huge difference. And so I really urge you to teach your students that strategy. Now, the second student is Dana. And she was a first-year student in physics. And Dana had made an 80 on the first test, 54 on the next test. And I actually met her in a Change Your Major workshop. Now, I wasn't teaching the workshop. I just wanted to see, what do they do in a Change Your Major workshop? And so I'll never forget this. The counselor who was doing the workshop had everybody introduce themselves and tell what major they were leaving and what they might be interested in. And so Dana stood up and she said, well, my name is Dana, and I was a physics major, but that's just not working out. And I'll never forget that what the counselor said was, "Oh, yeah, physics is hard. We will find you something you can do." And so I didn't stop her at the time, but as Dana was leaving, I said, "Dana, do you have about an hour that you could spend with me in the office?" And she said, "Sure." And I said, "I'm not going to try to talk you out of leaving physics, because if you want to do something else, that is absolutely fine with me. But I want you to know that you're leaving physics not because you can't do it, but because you've chosen to do something else." And so we met for an hour. She made 91 on the next test, 97, 90 on the final, A in the course, 4.0 that semester. And she ended up, she graduated from LSU a couple of years ago with a 3.7 cum GPA. She'd always wanted to be a medical physicist because she was from Houston, and her mom worked at the MD Anderson Cancer Center. And she knew a lot of the medical physicists there. And she was at LSU on a very prestigious American Physical Society scholarship for African American students. But she was ready to give all that up because she thought that she just couldn't do physics. And I talked with her a few weeks ago, and she graduated this past spring, and she's starting her residency. She got a full fellowship to do her master's at MD Anderson, and now she's starting her residency. So this kind of stuff actually can give students back their hopes and dreams, and can help them understand that there is a way that they can really master this. And so on the next couple of slides, and I will make this whole PowerPoint presentation available to you, not in PDF form, but in PowerPoint form. So if you want to take some of the slides and use them with your students, you can do that. And so the next couple of slides are just exactly what those two students did. Now, the thing about developing the text before, previewing it before reading and developing questions, that's what psychologists call developing an anticipatory set. And I will give you a little exercise that will demonstrate to you the power of an anticipatory set. And so I'm going to give you a minute to read that passage. Okay, I'm seeing some frowns and some, what in the world? Okay, and so if I took it off the screen and I asked if anybody thinks that they could come up and summarize what was in that passage. Anybody do that? Okay, is that a hand back there? Okay, have you seen it before? No, okay, interesting. Okay, that's exactly what it is, yes. And so my next question was, if you knew before you read it that it was about the first voyage of Christopher Columbus, and so I'm going to give you a second to read it again, and tell me if it reads differently this time than it did before. You see the difference? Yeah. Now we know what the three sturdy sisters were. Now we know about the egg, exactly. And so let me go back to the gentleman back there who saw Christopher Columbus in it before. What do you think allowed you to actually, your mind to go to that it was about Christopher Columbus? Were there any particular phrases in there that did it for you?
Just the gems and talking about the turbulent passage.
Okay, the Hawks gems, the turbulent passage. Yeah, and so that's really an indication that for the rest of us, when we didn't know, and I didn't know what it was about, and it didn't make any sense to me, and so we didn't have enough background information to connect this with that, but he had enough background information that he could connect some of these passages to Christopher Columbus's voyage. But when I show this to students, then they actually see that, if I know before I start to read what something is going to be about, then it makes a lot more sense. And they do that. And this is just the reference for that information. And so the other thing that I like to do is give students concrete experiences where I can't just tell them, you need to preview before you come to class or preview before you do the reading. They have to see that it makes a difference. Now, anticipatory set actually can interfere with learning. And so if we look at this car, is that a two-door car or a four-door car? I'm hearing, Okay. How many people think it's a two-door car? Okay. How many people think it's a four-door car? Okay. How many people are not sure at all? Okay, yeah, this is a car I rented a few months ago. And you know, it looked like it was a four-door car, but my anticipatory set said that the rear handle ought to be in a comparable position as the front door handle. So I thought, well, maybe this is a cop car or something, and not supposed to be able to open the rear door from outside. Who sees where you open the door to the rear? You see it? It's here. Okay? But my anticipatory set, I didn't even look up there, and it wasn't really prominent. I had the car for probably 4 hours before I realized that this was how you get in. And so the way this is relevant to our teaching, many of our students come with misconceptions. And those misconceptions really prevent them from really being able to understand. My misconception was that the rear handle was going to be here if the front handle was there. And I wasn't even looking up there. And so we have to make sure that we kind of test for understanding. And I'm not saying that we have to tell students everything, but we could, if we're going to talk about, let's say, cells, then you might ask, you know, can anybody just tell me in your own words exactly what is a cell? And if somebody says, well, it's the place where they put prisoners, then, you know, and that's funny, but I can tell you, I'll tell you a little story about it, and this happened in math, where this math professor was teaching about, it was developmental math, but he was teaching about how to calculate the volume of an object. And he said that he explained you multiply the length times the width times the height. And he said there was this one young lady in the front row who just seemed so confused by what he was saying. And so he did what we as faculty often do when students seem confused. We repeat what we just said, but louder. And so he said it louder, and she still looked really confused. So she came up after class, and he had a little object that he was using. He said she picked up the object, and she pointed at it, and she said, you keep talking about calculating the volume of this thing. I don't hear a sound coming out of here. Okay? And so often, when we are talking about things that we think our students should know, they really are clueless. And so we have to control for that. Now with Dana, and I didn't tell you exactly what her problem was, but Dana was actually having the problem that most students who are in quantitative courses, and even courses like biology courses where they've got to answer questions for homework, what many students do, and actually I'll ask you, how many of you, if you think back to every time you had to, let's say, turn in a problem set, how many of us, and I'll include myself because I did this too, how many of us would look at the problem that we had to work and then flip back in the chapter to find an example? If you ever did that, raise your hand. Okay, and we're faculty, and we did this. All of the students are doing this. And so now I did learn at Cornell, I said 99% of the stuff I didn't know before I got to LSU. This one thing I did know, the number one reason that my students in chemistry were making D's and F's on tests when they could have been making A's and B's was the way they were doing their homework. And so then I asked students, I said, okay, yeah, but when we did that, were we working the problem? Were we? No. And the students say no. What was working the problem? The book, the author, exactly. And then I said, okay, but if you're like me, when you, and these are very bright students, it's not that they are not bright. And I said, when you looked at the solution, the example, do you remember what went through your mind when you saw the way the author did it? Anybody remember what went through your mind when you saw it? Exactly, exactly. Of course. Oh, yeah, I can do that. But then when you get to the test or the quiz, if anything is a little bit different, then you're not going to do it, which is why so many students are thinking, well, I've never seen that kind of problem before, because they haven't, because it's not exactly like what was in the example. And so the solution that we give them, we tell them that what you've got to do is before you look at the first problem, you have to study the information. Study it as if it's going to be on a test or a quiz the next day. And in studying the information, you are going to come across examples. Whether you're using your notes or the textbook, you're going to come across examples. And I ask the students, right now, when you get to an example, what do you do? And what do you think they tell me they do? Who say that louder? No, actually, it's worse than that. Skip it. Now, I never skipped the examples. I mean, I would read it. They are all skipping the examples. And so I tell them that you've got to commit to yourself that you will never skip another example, because the examples are your brain's best resource for determining that it can work these problems without any external aids. And so what I tell them to do is study the information. When they get to an example, just read the problem statement and then work it on their own. And I said, and even if you get stuck, pretend like you're on a test and you have to get an answer, so power your way through until you get to an answer. And when you've gotten an answer, compare your answer to the answer that's in the book. If you got the same, bless you, if you got the same answer, then you can look at what the author did. But if you didn't get the same answer, don't look yet. Try to figure out where your mistake was. And then I ask students, I say, at this point in the process, do you think making a mistake is good or bad? And what do you think students tell me? That, okay. Believe it or not, and I hadn't realized there was going to be this dichotomy, but 99% of the time, and I've asked this to probably about 50 groups of faculty where I did a presentation to their students also, the faculty always say bad, the students always say good. Yeah, and so then I followed that up with, I say, now I'm not saying that it's bad if you don't make a mistake. It's great if you don't make a mistake, but why is it good if you make a mistake? And they are so dead on. What do you think they tell me? Exactly. They say you learn from your mistakes. Sometimes they say you're not going to make the same mistake twice. Sometimes they say you know where your brain has a tendency to go wrong. And so they see that if they make a mistake, that's not a bad thing. And then I ask them, and I'll ask you guys, how many of you ever got a test back and you looked at it and you said, oh, I made simple mistakes? Or how many of you had students who said, yeah. And I tell students that my attitude is there's no such thing as simple mistakes. Now, that's a little bit of an exaggeration because there are some, but in general, these mistakes that they're making are not simple mistakes. And I say, mistakes are things that have to be made. Your mistake only looks simple in retrospect. Once you know what the right thing is, your mistake looks so simple. But mistakes have to be made, and either you're going to make them before you get to the test or you're going to make them on the test. It is your choice. And I have so many students now who will go back and they will use this process. So if you do the examples that way, and I tell them, once you get to the actual homework, then pick 3 or 4 problems to do and just pretend that it is a test. Do them at a little bit more of a brisk clip. And after you've done that set, go back and check and make sure you've done them all correctly. And so you're getting all the mistakes out of your system before the test or the quiz. And what happens with students, if they've got something like biology where they might have to answer questions, they're just looking at the question, going back, reading that section of the book, and writing the answer directly from what's in the book. So what they'd have to do there is study the chapter, and then when they see those questions, answer the question without looking at the book. And then after they've answered the question, compare what they wrote to what was in the book and see what's missing in their answer so that they can fill that stuff in. So they're using the homework in the way that you intended them to use them. Now, online homework can be a great learning tool. How many of you use online homework systems? Okay, yeah, but it can be a detriment to student learning if it's used incorrectly. Students now have figured out how to game the system. Did you know? Yeah, especially if they can do if they have more than one chance to get the answer. And if they only lose a small percentage if they have to do it twice, if they incrementally lose more. I've seen examples where 4 or 5 students will get together and it's the buddy system. And each one of them will click in a different answer. And so one of them will get it right on the first try, but everybody else gets it right on the second try because now they know what the right answer is. But I find that giving students this information, and bless their hearts, as we say in Louisiana, they really don't think that this is detrimental to their learning. They really don't, because they think, well, if I know what the right answer is, then I'll get it right on the test. But I find, which was also a surprise to me, that students, when I explained this, they understood it. And so if we describe the homework in terms of effective learning strategies, it makes a big difference. There are these websites out there now. How many of you are familiar with Chegg? Okay, this is a student homework section where you see that 24/7 homework. Yeah, 24/7 study help. And this is the thing. Now, they have guided textbook solutions created by Chegg experts. 2,500 plus textbooks in math, science, engineering, business, and more. So all our books, they've got the solutions. And a student on this website can just go there and they will give them the solution. Now, Dana was using a form of this, and she has a lot of integrity, so she wasn't using it to cheat. She said she was just using it to get a hint of how to start the problem. But I said, okay, but do you get a hint on the test? And she understood, no, she didn't, and that she was really sabotaging herself. And then she stopped that, and that's when she started making A's. And so basically, students can make this huge increase because it really is all about the strategies. And if we know how to teach them the strategies, it makes a big difference. And so I'm going to do a little exercise with you now. Now, I know quite a few of you have seen presentations I've done. And so how many people have seen this exercise before? Oh, okay, not as many as I thought. Okay, so don't give it away if you've seen it. Okay, but what I'm going to do is on the next slide, there are a series of words or short phrases. And I want to see how accurately you can count the vowels in the words on this next slide. And so I'm going to give you 45 seconds to do it. If you finish before 45 seconds are up, then just go back and make sure that you got them exactly the right number. But we all have to stop at 45 seconds, so I will give you the 5-second warning when we have to stop. Is everybody ready? Okay, so let's start counting the vowels now. Five seconds. And stop. Okay, so now what I want to know is how many of the words, how many of the items on the list, words or phrases, do you remember? And if you're sharing the clicker, then just kind of get an average of the number that, that the two of you remembered. And it's only for people who haven't seen this before. Okay, and then vote. And go ahead and vote when you get the number. Okay, I'm going to give you the 5-second warning. Okay, so go ahead and click in if you have not. Okay. So 0 to 1, 2 to 5, a few, 6 to 8. Okay, so I'm going to say, since there were quite a few that said 6 to 8, I'm going to be fairly generous, and I'm going to say that our average, I'm going to give us 5 on that. Now, 5 out of, there are 15 words on the list. 5 out of 15 is what percent? What letter grade is that? Okay, kind of F. Okay, now I'm going to put the words up again, and I want you to look at them from top to bottom. And if you haven't seen this before, now you will notice if you look at them from top to bottom, they're arranged according to something. Anybody see what, if you see what they're arranged according to, yell it out. Numbers. Numbers. Dollar bill for 1, dice for 2, tricycle, 4-leaf clover, hand, 6-pack, etc. Okay, so now what I'm going to do is I'm going to give you 45 seconds now to memorize the words or phrases on the list. And this time, after 45 seconds are up, I'm going to take them off the screen, and I want you to just close your eyes, and in complete silence, please, just silently recite them to yourself to see how many you remember, and then open up your eyes when you think you've remembered as many as you're going to remember, and again, consult with your clicker partners, and then weigh in on the number you remember. So let's start memorizing the words or phrases now. 5 seconds. And stop. So just close your eyes and silently recite them to yourself. Okay, so get with your clicker partner and figure out how many you think you remembered this time, and then vote. Oh. Okay, I'm going to give you the 5-second warning. Wow. Okay, so 12 to 14 or 15. So this time I'm going to say about 13 maybe. Now, and 13 is about 87%. And so the point of this exercise is this: we are not any smarter people in the room than we were 5 minutes ago when our average was an F, 33. And just as we could move from 33 to 87% in about 5 minutes, our students can do the same thing. Now, there were two major differences between the first and the second try. What was one of the differences? Exactly, exactly. We knew what the task was. I threw you off. I said I wanted you to count the vowels. Well, the way this translates to our students, when we have to be very careful to make sure they know what the task is. When my faculty members told me, professors said, I want you to turn in these problems for homework, I thought the task was to turn in the problems done correctly. That's what I did using the examples. That's not what they meant. They meant I want you to be able to work these problems and problems that are similar to this problem by understanding the information. And so if our students don't know exactly what the task is, if we say I want you to read chapter 3, if they think that means just have their eyes fall over every other word while they're Facebooking and texting, but if we really mean I want you to be able to come up and teach this material to the class when you come back, very, very different tasks. And students won't know what it is unless we tell them. So that was one difference. What was the other major difference? Exactly. We knew how the information was organized. We had a way of connecting the information to something we were very familiar with, the number system. And that's another cognitive science principle. Every time the brain learns something new, it is trying to connect it to something that it already knows. And so if when we're teaching concepts, we can help students connect this information to something they're familiar with, it makes a big difference. And again, we don't have to tell them, because I found that the less we tell students and the more they figure out for themselves, the deeper the learning. So we could just ask, what does this remind you of? Does this remind you of anything? And it doesn't have to be anything that's specifically related to chemistry, but just something where they can connect the information. And once they know how that's organized, it makes a big difference. And I find that we as faculty very often don't do that. We give students the what of the information, but we don't take the time to help them figure out the whys, the hows, and the what ifs, because we don't have enough time. We're trying to cover too much stuff. And so, but that's extremely important. We knew what the task was, and we knew how the information was organized. Now, you heard me say that as recently as 14 years ago, I did not know this stuff. And so when I started reading everything I got my hands on, how people learn was one of the things that I started with. excellent book, published by the National Academy Press. If you Google this, I mean, it's free now. You can just get a PDF version of it. And I found a lot of very useful information in that. And some of the things that we know about learning are active learning is much more lasting than passive learning. When we get students engaged, we've all heard this. But we know that thinking about thinking is very important. And even using the term metacognition for students is extremely important so that they understand that they have control over their thought process. And then the level at which learning occurs is extremely important. And that's where Bloom's taxonomy comes in. And we do know that there's an older version and a newer version now. And how many of you are still using the old version of Bloom's? Anybody? Okay, I find it makes absolutely no difference which version we teach students. Oh, how many of you actively teach Bloom's to your students? Ah, very few. Okay, yeah. I'm going to suggest that you actively teach Bloom's. That's what they were doing also when I got to LSU. And I knew Bloom's because my PhD is actually in chemical education, but I learned it as a tool for faculty, for us to target our instruction, target our assessment, but not as a learning tool for students. And so I never taught it to students, but they were teaching it with great success, and so I started teaching it. And students were saying, wow, I wish I'd known this when I was in high school. Now, as you see, and somebody mentioned earlier, and I think it might have been Ellen, because she has a different form of Bloom's where it doesn't have the triangle, and I think the other form is great, but I love the triangle form, because what is the base of that triangle? Remembering, yeah, and I have so many students who are trying to apply stuff, but they haven't taken the time to memorize the information that they have to memorize. I actually had one young lady, we were doing problems in chemistry, and I asked her, well, how do you calculate the mole? Well, she didn't know. And I said, well, there's certain things that you have to memorize. And she says, oh, no, our professor told us this course is not about memorization. This course is about applying. She didn't know anything. And so, and so, I mean, you can't apply something unless you have mastery of the content. And so I like to use this form because it shows that, you do have to spend some time memorizing some things because that's the base. But it isn't, hierarchical in this sense necessarily, but I still like this form and I use it with students. And on the next slide, this is just the way we explain it to students, each of the phases. And typically they have never seen Bloom's. And so then we ask them, well, I was going to tell you, when we teach them Bloom's, students get it. It's like the light bulb goes on for them. And this is another clicker question, and so I'm going to ask you, I was teaching a class of students, there were about 250 students, and we were using clickers. And after explaining Bloom's taxonomy to them, I asked them, at what level did you have to operate to make A's and B's in high school? And just click in and tell me what level you think they said. Okay, 5 seconds. And very interesting. Now, I think that you're on target, but I'm going to show you 3 years worth of data. In 2008, this is what students said. But now these are the same students. Sometimes I ask students, what did your teachers in high school do the day before the test? And what do you think they tell me? Review. I expected, somebody said gave them the answers. Most of them said review. Most of them said review. I expected that, but when I asked them what did they do during the review, many of them said they gave us the answers to the test. And so I think these kids were kind of off base because if they just, when I asked them what grade would you have made on the test if you had not gone to class a day before, just the day before the test, you went to the class that day, paid really close attention to the information, they tell me B. Usually, there's a few students who say A, a few say C, most of them say B. Okay, but in 2013, this is what they said. But in 2014, I just did it with a group of students last week, and so they were back saying, more understanding. But the bottom line is they see that they were at the lower levels when they were in high school. And then when I ask them, at what level do you think you'll need to operate to make A's in your college courses, the A's you're capable of making, click in and tell me what you think what level you think they say. Okay, vote now. I'm going to give you the 5-second warning. Okay, okay. You're close. You're close to what they said. You said applying, analyzing. Okay, in 2008, they said analyzing, and so they actually realized that it was higher than applying. In 2013, same thing. They realized that they needed to be at analyzing. Now, this group that I worked with last week, yeah, they said creating, but this was an honors group, and actually for a lot of their courses, they do have to be at creating. And so the bottom line is they recognize that this is the third piece of the puzzle. They were in study mode and not learn mode. They were working to make an A, not teach the material, and they were working at the wrong level. So how do we teach them to move to higher levels? And that's where this study cycle comes in that April was talking about. And we teach this to students. And you can print out this slide, you can give it out to students, but it's just a very simple study system where the very first thing is preview material before you go to class. Spend about 10 minutes or so looking at the boldface print, the italicized words, so you know what's going to be covered in lecture. Then the second step is go to class. You have to be in class. You got to be there. But now, believe it or not, a lot of students miss class because they really don't think they have to be there. They think they can do what? Okay, somebody said sleep. But how are they going to get the information if they don't go to class? Exactly. They're going to get it from the PowerPoint. They're going to get it from a friend of theirs. And yeah, so they don't realize that they need to be in class. And then the third thing is review the information that was covered in class as soon after class as possible. And the evidence that we give them there is, and I'll ask, when you first hear something, what part of memory does it go into? Short term. If you don't do something to move it into long-term memory, that information is not going to be available to you. And so we say that as soon after class as possible, you got to review the stuff, because then you're starting the process of moving it from short-term to long-term memory. Take about 10 minutes or so to do it, but you got to do more studying than just the 10-minute preview, 10-minute review. And so we call that intense study sessions, and we show them how to structure that. Set aside about 45 minutes to an hour to 75 minutes. Take a minute or so to set a goal. Then study with focus and action. Turn off the cell phone. Turn off Facebook. Really concentrate. Organize, do some concept mapping, work some problems, and then 10 to 15 minutes, reward yourself, and then come back and review and go over what you've just studied. And then do another one if you have time. And what we tell students is if you can do 2 or 3 of these during daylight hours, if you do another 1 or 2 at night, you will have studied for 4 or 5 hours that day. And it doesn't seem like it's that much studying because you're doing it in short bursts of time. And believe it or not, students will do this. I was very surprised, but they will do it, and that's really, and we knew all along that if they start putting brain power, if they put time into this, then they can be successful, and this is a system that allows them to do that. Now, I did say that it's very difficult to talk about metacognition and detailed learning strategies the first day, but there are some things you can do. There's a metacognitive get acquainted activity where if you have students just work in groups of 2 or 3, so you're creating this community of scholars in your classroom, and then just have them answer the questions, what do you believe is important to understand and learn in microbiology? What do you believe to be critical characteristics of students in immunology? How will you study and prepare for exams in biochemistry? And have them write that out so that from the beginning of the course, they're not thinking that they're just going to study the night before and ace the test, which is what they have a tendency to think. 2 additional valuable resources, Teaching Unprepared Students by Kathleen Gabriel, and then Linda Nilsson, it came out in 2013, Creating Self-Regulated Learners. And she has a lot of activities that you can do as the course goes along to help these students become self-regulated. And now there are a lot of other institutions, people are recognizing that this tool is very powerful. At CUNY's math department, how students can improve by studying themselves. At 2010 Chronicle of Higher Education, just October 2013, RIT has a program that will teach first-year students how to learn. And then a couple of other valuable resources, Mindset, as we come to a close. This is work that was done by Carol Dweck. How many people are familiar with Dweck's work on Mindset? Not that many people, okay. And then in 2010, David Shank did the follow-up on the genius in all of us, why everything you've been told about genetics, talent, and IQ is wrong. And what Dweck found is that most people have one of two views of intelligence. Either they think that your intelligence is pretty static, you have a certain amount of it that you're born with, and you can't really change that very much, or they think that you can develop your intelligence with your actions. And it turns out that your view of intelligence has a lot to do with the actions that you will exhibit when it comes to learning tasks. And what she's found is that your reactions to a lot of things are based on your mindset. Challenges. People with a fixed intelligence mindset want to avoid challenges because they don't want anything to show that they're less smart than they perceive themselves to be. But people with a growth intelligence mentality embrace challenges because they know that's the way to get better. Any obstacles or tasks requiring effort, these people give up very easily. They think it's fruitless to put forth effort because either I'm smart enough to do it without working or I'm not smart enough to do it at all. So why am I going to put a lot of time into this? Whereas with the growth mindset, they persist through obstacles, and they know that effort is the path to mastery. And they have different reactions even to criticism and to the success of others. And so what I want to know now is, and this is just a little diagram that shows, if you have a growth intelligence mindset, and the studies in brain plasticity and things like that, we know that the growth intelligence mindset is much closer to the truth. You grow. As a result, these people reach very high levels of achievement, whereas these people just don't grow any more than when they came in. And so what I would like to know now is, the question is, which mindset about intelligence do you think most students have? Do you think they have a fixed idea of intelligence, or do they have a growth view of intelligence? And so get with your partner and click in, please. Okay, we're at 33. 5-second warning. Okay, so we said fixed, and I totally agree with that. And I think for good reason, because students saw, when they were in elementary school, they saw the blue group, the red group, the green group. They knew what those groups meant. And when they got to high school, had the pecking order changed at all? No, the bright kids were still the bright kids, the other kids were, and so they definitely have typically a fixed mindset. Now I want to know, what mindset about intelligence do you think most faculty have? If you would click on that, please. Be very honest. Just of intelligence in general, yeah, of the general population, of people, yeah. Okay, 5-second warning. Okay, now I got one more question, and that is, what view of intelligence do you think most STEM faculty have? And the reason I threw that in, I was at a conference once, and I asked the question, what view of intelligence do you think most faculty have? And somebody from the audience said, are you talking about STEM faculty? And so, okay, so go ahead and vote here, and we will see if it's any different. Interesting, very interesting. Okay, and their view was actually just the opposite, that many people in science tend to think that there are students who are smart. I know, I thought this. I thought that there were certain students who were smart enough to ace organic chemistry, and if students flunked the first couple of tests, then they just weren't cut out to be the doctors that they saw themselves to be. I don't believe that anymore, but this is very interesting that you think most STEM faculty have a growth mentality. And I'll be around for the conference. I'm going to engage some of you in that conversation. And so as I close, I just want to share with you a couple of other emails. This is from a general chemistry student in spring 2011, and he sends me this email. Personally, I'm not so good at chemistry, and my grades are reflecting that. I want to know if you can tutor me. And I didn't spend 1 nanosecond tutoring this guy. I gave him 1 hour session on learning strategies, and as you see, he emailed me, he made an A in the course, and I asked him exactly what did you do differently. And I told him, send me his scores. And so he sent me the scores. This 50 got dropped. These were his scores before we met. These were the scores after, and he made a 90 on the final. But he started with a 60. He said, I think what I did different was make side notes in each chapter, and as I progressed onto the next chapter, I was able to refer to these notes. I would say that in chemistry, everything builds from the previous topic. Now, imagine that. Okay. And, but the point is, our students don't get that. Now, of course, he would get that, because we talked about that in the session. But it's fine if he thinks it's his epiphany. At least he's got it now. Now, when we teach metacognitive learning strategies to whole classes, after the first exam, this was a general chemistry class, we found that the end of course grade was a whole letter higher. On the first test, the averages were pretty much the same, no statistical difference. Exam 2, the people who were there went up to 77. These people went down to 69. On the final course average, 81.6 versus 70.43. And we've published an article on this, and it came out in the Journal of Chemical Education last fall, and I was working with a colleague, Peter Zhao at East Tennessee State, who did it. I did a talk at a Gordon conference, and I asked if anybody was willing to try this. And Peter was the only one who tried it, and he tried it, and he got exactly the same results. And so we published in Journal of College Science Teaching. Roald Hoffman, a Nobel Prize winner, and I put something in Science. He'd not seen these ideas, and also something in the American Scientist. And the thing that is motivational for students is showing them what works for other students. And so I had given an exam after going over the strategies, and there were certain students who used them, certain students who didn't. And so I just sent out a little survey, and I asked the students who didn't do well what they think was the reason, which strategies that we had talked about didn't they use that they think was responsible for their low grade. And for the students who got an A, I asked them, what did they use? Students who didn't do well, didn't spend enough time, started the homework too late, because to use that problem-solving strategy, I tell students, you have to start the homework early. You can't wait until the night before. They didn't memorize the information they needed to memorize. They didn't use the book. They assumed they understood information that they'd read and reread but hadn't applied. The top 5 reasons that students made an A, they did the preview review for every class. They did a little of the homework at a time. They used the book and did the suggested problems, not just the required problems, but they did additional problems. They made flashcards of anything they had to memorize, and they practiced explaining the information to others. And so when I was talking at New Mexico State last October, there was an engineering professor in the audience, and he saw that information. And so his next class period, he showed that to his students, and he did a little self-report survey, and he asked them to identify whether they were more like the students who didn't do well in terms of strategies, or more like the students who made an A. And so they indicated to him which group they fell into, and he said he was shocked when he looked up the averages. He found that the students who weren't using the strategies, 58 and 54 on the first 2 exams, these were 95 and 80. So then he went back and he showed that to the class to encourage those students to use the strategies, and he said his average on the next exam went up 10 points. He had never seen that. And so it really helps. Changes that other faculty have made, just telling students this learning strategies information, but doing it by way of reflection questions so that they come up with the information. A math professor at Miles College said all he did was he increased the frequency of exams from from 3 per semester to bi-weekly, presenting the learning strategy session and then teaching students that reading strategy. And so the bottom line is, okay, when we look at more impact, this particular student, okay, yeah, I read this. This was from the email that I read you from Sydney. Works with graduate students. This one graduate student had failed all of his human exams the first year except for one. We taught him these strategies. The next year he passed, they passed 6 a year. We give them 8 a year. They've got to pass 6 before they can continue in the PhD program. He passed 5 out of 7 this year and passed the December exam with the highest score in the group. And this is he, Dr. Algernon Kelly. take a good look at him. This is the only person I know on the planet who has a PhD in chemistry, he's an analytical chemist, who started off in all developmental courses when he started college. Every single course was a developmental course. And he now teaches this to his students, and so he sends me emails. I send him emails, success. And this series of emails I just want to share with you. October 17th, he was teaching at Xavier at the time. He's at SUNY Brockport now. This guy writes him, "Hello, Dr. Kelly. I'm struggling. I really want to succeed, but everything I've tried seems to end with a decent grade. I was hoping you could mentor me." So Al taught him these strategies. 1 week later, he says from "Hello, Dr. Kelly" to "Hey, Dr. Kelly, made an 84 on my chemistry exam compared to the 56 on my first one using your method for 2 days without prior intense studying." And then November 3rd, from "Hello, Dr. Kelly, hey, Dr. Kelly, hey, Dr. Kelly," increased my bio exam grade from 76 to a 91.5. Ever since I started using the study cycle program, my grades have significantly improved. I've honestly gained a sense of hope and confidence. And that's what we want to give to our students, hope and confidence. My family and I are really grateful that you've taken the time to get me on track. Those of us who have first-generation students, when they don't do well, their parents, they don't know how to help them. And I never knew that it was this easy to teach students strategies, and they would be able to do that. Now, knowledge of metacognition really increases the success of underrepresented minority students because many of them are less likely to have been cognitively challenged in high school, more likely to feel that they don't necessarily belong, especially if they are at a PWI, predominantly white institution, more likely to think that initial failure means that they might not be smart enough, more likely to feel that the other students and the professor don't respect them. And there are a lot of actual real incidents that happen in classrooms that would suggest that. And this is from the article that came out in the May 2014 issue of Physics Today. And this is the article. Social psychologists address these barriers, psychological insights for improved physics teaching, and you will see this chart, but they talk about how very small interventions yield big improvements. Just helping students know that if you fail the first test, that doesn't mean that you're not smart enough. It's all about the strategies, and in this table they talk about what they're doing. Now, does this method work for all students? No. And so I have found that there are 3 categories of students for whom it doesn't work. There are probably more. One is the students who refuse to take any personal responsibility for anything. Because if they think everything is somebody else's fault, they're not going to try this because they don't think it's their fault that they're not doing well. Students who just have no time to implement the strategies, it does take time. If you're working 50 hours a week, and taking 20 hours, it's not going to work. And then the students for whom the gap between the level of skills required for the course and the skills they bring to the environment, that gap is just too big. And after I wrote this, I was thinking, these are the same categories of faculty who the kind of stuff that you're doing is not going to work for. Faculty who refuse to take any personal responsibility for student learning. Faculty who say, I don't have time to do this. I'm busy doing research. And they just don't want to learn this. So that's something to think about. And, but when we know the barriers, they can definitely be addressed. And the studies tell us that we can significantly increase learning if we teach students how to learn, if we make learning visible, make the implicit explicit, don't judge their potential on their initial performance, and don't let them do it either. Encourage them to use metacognitive tools, and support the campus learning center, because these are the people on our campuses who kind of know this stuff. But as I go around the country talking, I find that many times the STEM faculty and the learning center community folks, 2 different communities that don't talk to each other. And so you may find that that's a great resource. So 2 final questions, and then I'm going to shut up and let you out of here. Okay, now if you had to answer the question, who's primarily responsible for student learning? And I know all of these entities are, but if you had to pick just one to say who's primarily responsible for student learning, which would you say? Is it the student? Is it the faculty member? Or is it the institution? And so when we get to about 25, I'm going to see. So who's primarily responsible for student learning? Okay, we're at 30. Here's the 5-second warning. Okay, and yes, 86 at 3, okay. Now, who do you think students say is primarily responsible for student learning? So, vote on that one. And let's see. Oh, we're up to 39. Okay, so let's see what you think. Um, Yeah, they say, well, they tell me, well, if they don't teach it, I can't learn it. And so I said, okay, but if your learning were 100% your responsibility, is there anything you could do differently? And they kind of go, oh, yeah. And I ask us as faculty, if our student learning were 100% our responsibility, is there anything we could do differently? And I'm saying, and that's why you're here. Yeah, we know there's stuff we can do differently. And if we asked our institutions the same question, the answer would be yes. All of us have institutional policies that are mitigating against learning. And so the bottom line is that when all three of these entities come to the table, taking full responsibility for student learning, that's when we're going to see a significant increase in student learning and retention, graduation rates, and achievement of those SERP and POLS goals. And so this is a special note. This is our website that April was talking about that has a lot of resources, and this is my email address up there. And these are some additional very helpful websites and some additional references. And I just want to say good luck, and as you teach your students these powerful metacognitive strategies, and have fun with your students. So thank you very much. You've been great. Thank you. And thank you. Okay, and I know it's exactly 8:30, which is what time we said we'd let you out of here, but I can take about 5 minutes or so worth of questions if people have questions. Yes?
Thank you for, this is exactly what I needed to hear. But the whole thing about waiting for the first test.
Yeah, yeah. Yeah, the question is about waiting for the first test in order to give this. And what I did, because so many faculty say, well, I don't really have time, I can't take time out of a busy schedule to do this. I think best case scenario might be to mention some of this stuff early on, and then after the first test, revisit it and reinforce it. But if you only have time to do it once, then it's more effective if you do it after the first test. But now I suggest to faculty, I'm very different. I was very different when I retired than when I started. I used to give my first test about 4 to 5 weeks into the semester when I'd gotten enough stuff to cover. Now I urge us as faculty to give the first assessment within the first 2 to 3 weeks at most, because students need a data point from us about what we are requiring. Some of us want students to count those vowels very accurately, don't miss a vowel. Others of us want students to write a paragraph using the words on the list. And I'm not suggesting that one is more appropriate than the other, it's just very different. And students need to know what we are looking for, and if they don't have a data point from us, then they won't have that. And if they get the data point too late, if it's not until 6 weeks in, see, because once they know what it's about, what we are about, they now got to start back to the beginning of the course. And they're on dual tracks for a while, because they've got to learn that stuff and until they get caught up. And if it's too far in the semester, then it's just going to be too daunting. And so, but you could try it at the beginning, and some people probably do. I just found that it was more a waste of time because people just were not listening. There might be a few people who were. One thing you could do before the first test is send students to that website, because we have online workshops and students can do that on their own. But I found that the best use of my class time was to wait until after the first tests. Great question. Oh, yes.
We did the example where we didn't know the task.
Right.
And the comparable situation with students is we teach them the material, and then I'll do a review session and say, okay, what could I ask you?
Right.
What do you think I will ask you on the exam? And they go,
Exactly. Yeah, when we say, what do you think I'll ask you on the exam? And that's because they have no strategies for how do I even come up with questions. And one very simple strategy is just have them use the textbook, and they'll see what the headers are, what the italicized words are. Have them just turn the statements around to questions. So for example, if the statement is a weak acid is an acid that does not completely dissociate in water, then the question might be what type of acid does not completely dissociate in water? Or it could be what is a weak acid? Or it could be what's the difference between a weak acid and a strong acid? And once we give them that kind of information to get them started, then they can kind of go from that. Yeah, but we do really have to model what we're wanting students to do, because they will totally be at a loss for how to come up with questions. Great question. Okay, yes. Okay.
I was actually asking
Yeah,
Then I asked them, okay, why were you not in the right?
exactly.
Well, I asked them to define the other terms in there. Or
Yes,
how they relate to one another. So then they have to start thinking about all the
absolutely.
scenarios, all the
Yes.
other things.
Absolutely, yeah, that's a great learning tool, the Jeopardy game, and they have to explain why the wrong answers are the wrong answers, because that's when they uncover a lot of misconceptions. And somebody mentioned review sessions, because the students all want us to give a review session. And so I'm working with a psychology professor, and we're going to do a presentation at a conference, but what she had students do was develop their own review session. She broke the class up in groups, and each group had a different chapter, and they had to prepare a review session for the class. And so I think as faculty, we've been doing way too much work, and the students haven't been doing enough. And so they can do their own reviews, and they could even prepare a Jeopardy game. They can do this, it's just that nobody's ever required them to do. Okay, and I'm sensitive, I don't want to keep people too long, so I'm going to take one other question. I can stay here till midnight, and I'm serious, but I don't want to keep everybody else here. And so I'm going to take one other question, and then I will be here, so if other people have questions, you can just come up and ask me. Is that okay? Okay, so yes.
More of a general comment.
Okay.
One of my favorite review sessions is to tell students we have an hour and a half, we're only going to answer one question. And so if they have a question, someone else at the review session has to answer that question.
Ah,
So if they get stuck, like, are you sure you want me to answer?
right. Yeah. Yeah, that's a great strategy. And supplemental instruction, how many of you do SI? Okay, yeah, that's a great tool. I'll talk a little bit about that tomorrow. But it's when their peers do, it's peer-led team learning. So it's not really a review session. They're talking about how to learn the information, and a lot of students get a lot out of that. So again, thank you guys so much. You were great. Nobody went to sleep, so even after all that wine and food. So, all right, thank you.